This question demands something simple from us, and we are going to fix it using very simple approach. The question is, using the diagram below, calculate the potential difference. So we are going to calculate the potential difference across resistor 20 ohms, okay? That's what it means. And we need to neglect the internal resistance. We need to neglect the internal resistance of the cell. So it has nothing to do with the cell, all right? Okay, so what do we do? The first thing we need to do here is to analyze the circuit in the first place, all right? The total current flowing in the circuit is not given. The value of the cell is not given as well. All right, this is the key. At this point, we have current 1, 2 amps flowing into resistance 1, right? This is resistance 1, right? This is resistor 2, okay, with resistance 10 ohms, resistor 1 with resistance 2 ohms. So we need to find out what happens here. Okay, if we have current 1 flowing into resistor 1 as 2 amps, of course, it's going to come at this point to flow into resistor 20 ohms, okay? Into the resistor 3, this should be resistor 3 with 20 ohms, okay? These currents, we don't know the value of current 2, is going to flow down to this point, and then recombine with current 1 coming through this way to flow into resistor 3 with 20 ohms value. So the question is, we should find the potential difference across the 20 ohm. We need to find the potential difference here, PD, across this 20 ohms resistance. So that's what it means. How do we start, or how do we approach this question? Very simple. We concentrate on what we have here. We concentrate on what we have here. We have current, we have resistance. So we can find the value of potential drop at this point. Don't forget that this is a parallel arrangement of two resistors with different resistances. This section has to do with parallel arrangement of two resistors with different resistances. By the time we resolve this, we reconnect this to be in series with this. Then we'll be able to find the potential difference across 20 ohm resistance, okay? So what do? We quickly apply Ohm's law. V is equal to IR, okay? This time around is going to be I1 and then R1. We are taking this. So for, and also potential difference across I1, okay? Potential difference across the R1, okay? That's what we're going to consider first. And that becomes the I1 is 2 amps, R1 is 2 ohms. So 2 times 2, this will give us V1 is equal to 4 volts, okay? We have the potential difference across R1, that is resistor 1. So with this, what next do we do? We also recall, by the time this current comes to this point, it will combine with this, okay? And then flow into this. We need to find the current I2, all right? So we need to find current I2, and there's this junction here that combines R1 and then R2, or where R1 and R2 combine or meet. So we need to use that to find the value of current flowing into this. Now we have found V1, okay? We need to understand, we recall that V1 is also equal to V2. You know the reason? The potential difference across two resistors connected in parallel is the same. Only the current is different. We are going to find out now. I repeat, the potential difference across two resistors connected in parallel is always the same. Only the currents flowing in each of them is different. Right? So with that idea, since we have V1 to be 4 volts, All right? It means that V2 is also 4 volts. So what do? We apply Ohm's law again, but this time around is going to be V2 is equals to I2 R2. Good. So quickly we substitute. For I2, we are looking for it. All right? We don't have it. For R2 is 10 ohms, right? And then we have V2 is also 4 volts. So what do we do at this point? We make I2 the subject. Once we make I2 the subject, we now find the value of I2. So I2, that is current flowing into resistor 2, is equal to 4 all over 10, and this will give us 0.5, if I'm not wrong. Okay, 10 goes against 4 cannot, all right? Cannot. So, or we can split it further for simplicity's sake. For simplicity's sake, you can go further. 2 divide 4 is 2, all right? 2 divide 10 is going to be 5. So here, we can now do simple 5 divide 2 cannot. We put down 0, put point, and then add 0 here. 5 divide 20 is going to be 4. So, we now know that the current flowing into resistor 2, whose resistance is 10 ohms, is 0.4 amps. So, I2 is 0.4 amps. Alright, so we have that. We now have I1 is given as 2 amps, alright? I2 is given as 0.4 amps, right? Very simple. Therefore, we can now find the total current. We can now find the total current flowing into the entire circuit. So I subscript capital T is now I1 plus I2. And this gives us substitutes. For I1 is 2, for I2 is 0.4. Therefore, IT, total current flowing, is equal to 2.4 amps. Now we have found this. Alright? We now know this is the total current flowing in the system from this point. Alright? This should be the sign, okay? From this point, the total current flowing into the system recombines at this point, okay? And then flow into resistor 3, whose value is 20 ohms. We can now find the potential drop at this point by using Ohm's law again. The third time we have used the Ohm's law the first time, use it the second time, we are going to use it the third time. And using it the third time, we have V3. V3 represents potential drop across resistor 3. And that is equal to I total, no longer I3. I total is multiplying with R3. So our I total is 2.4 times I3, which is 20 ohms. Okay? Let's look at this very well. Very simple. Okay? So what do? We simplify again. Here we can now say 24 over 10 because of this point. I am reverting it towards fraction to enable me clear out without using a calculator. And that means we continue with that 20 all over 1. So 0 will take care of 0 at this point. Alright? 0 will take care of 0 at this point. This goes. And we are left with 24 and 2. 24 times 2 is going to be 48. 48 volts. Right? It implies that V3 is equal to 48 volts. Solved. Oh my goodness. Thank you for watching up to this moment. My returning subscribers, thank you so much. My new subscribers, please do stay, remain connected, subscribe, share with your friends, students, and networks, Don't forget to put on the bell button for constant notification. I will always be there to feed with content with this. Teaching, learning continues. Alright, see you in my next class. If you have any question, if you have any conflict with what I have just done, put it in the comment section. Comment in the section box. Tell me this is where you did not understand, that you want me to put more explanation to that. I will do that for your learning pleasure, alright? Once again, thank you, and I'll see you in my next class.